So, welcome students. So, in the series of lectures that we have done for geometry, as was discussed, as I promised you, that we will be now coming up with the some PYQs. So, we may take 1 or 2 sessions. Today I am starting 1 or 2 sessions of previous year questions. We went through right from the basics of geometry to the heart or circles and all, and followed by the algebraic and trigonometric methodologies to deal with the situation. In radius, x radius, we went through all the things. So, I have chosen some problems from previous year questions 24, 23, 22, so that you get a feeling of what exactly you do when you solve a problem. Okay. So, without much ado about anything and without wasting much of your time, let us now proceed. So, this is a question, this is one of the easiest questions that has been asked, So, sometimes you wonder why questions like these appear, you may feel shocked when you see the solution. Okay, so let ABCD be a quadrilateral, angle ADC is 70 degree. A, B, suppose A, B, C, D. Okay. Angle BAD. Okay. This is 110 degree. So this is 110 degree. Okay. Now ADC is 70 degree. ADC is 70 degree. Okay. And ACD. AD, this is 70 degree. This is 70 degree. ACB. Angle ACB is 10 degree. This is 10 degree. Okay. So, you have to find the measure of angle CAB. So, this is our question. Okay. So, this angle is 40 degree. Fine. Now, if this is 40, okay, now we have to find CAB. So, this is the angle that we need. ADC is 70 degree, ACB is 10 degree, BAD is 110 degree, sorry. BAD, sorry. BAD, this is 110 degree. ACD, ADC is 70 degree and ACD, ADC, ACD, okay. So, let me draw an equilateral triangle, okay. This is 110 degree, ADC 70 degree, and then ACD is also 70 degree, CAB. How come? BAD is given to you as 110 degree. So, this becomes 40 degree. BAD is 110 degrees. So, CAB is going to be 70 degree. What is the use of ACB being 10 degree? Again, that is what I told you, that this is one of the easiest problems that you can think of. Probably They wanted to ask something else. It turned out that incidentally they have asked this. So, this is basically, even your school text might have, this also gives you the situation that these two are parallel. Okay, 70 degree, 70 degree, 70 degree, 110 degree, ADC. Okay, again we don't expect such easy problems, but this is the problem of 24 or 23, I don't exact, 24 most probably. So, you also can, you rarely get problems of this nature. In fact, even I was surprised when I solved this problem, that am I missing something, you know. So, we generally don't expect questions of this nature. Now, this is, consider a square ABCD of side length 16, EF be the points on CD. So, I have chosen problems sequentially, okay, from very easy problems to reasonable, and then we will move ahead. ABCD, EFB points on CD. CD is the C, okay. You divide it in the ratio, you trisect it. CE is EF is FD. Line BF and AE. BF and AE meet at M. So, area of triangle MEB. So, this is 16. Okay. Now, this is 16 by 3. This is 16 by 3. This is 16 by 3. Okay. So, triangle MEF is similar to triangle MAB. Okay. So, you have to find area of triangle MAB. So, if this height is h, this height is going to be 3h, and this whole height is 16. 4h is 16. So, this is 12 and this is 4. So, area of triangle MAB is very simple, half 12 into 16. This is 96 square units. So, 2 marks problem on occasions may be demanding, but on occasions they may turn out to be very, very reasonable. These are the problems that we are expected to definitely solve. Easy problems, we must have a knack of picking what are the problems which are reasonable in nature and then proceed. That will be a very, very important factor in attaining the maximum possible potential that you have. Okay. So, these again you see, these are very simple problems. Even in our classes that we took, in the sessions that we have taken, you would have seen that the problems there were comparatively more demanding. These would have been the problems at the very, very initial stages. But whatever we have gone through in the initial stages do hold key as we move on, and on occasions they are specifically asked. So, similarity, congruency, parallelogram, parallelism, those things, alternate, uh, opposite angle, vertically opposite angle, these things are to be kept in mind at all points of time. Fine. This is a bit problem, bit lengthy. Let ABC be a triangle in XY plane where B is at origin. BCB produce 2D such that BC is to CD is 1:1. So, let me draw the figure in a separate sheet. See, BC is produced to D. First, followed by CAB produced to E such that CA is to AE. CA is to AE. Okay, so let me explain. Suppose this is point A. This is produced to E. This is 1:2. CA is to AE is 1:2. AB be produced to F such that AB is to BF? Okay, is AB is to BF is 1:3. Is 1:3. Now, be the centroid of triangle ABC. Okay. And AB is produced such that AB is to BF is 1:3. Write G, centroid of triangle ABC. Okay, centroid of triangle ABC G is given as 32, 24. Now DEF. DEF. This is given to you as origin. GK. Okay. Centroid of DEF is said to be K. Okay. Now, since coordinates are given, let us utilize B is 0, 0. This is say alpha, beta. So this is 2 alpha, 2 beta. Say vertex A is gamma, delta. Now in coordinate geometry, you would have gone through all of these things. Okay, this is primarily a problem of coordinate geometry, not pure geometry. Pure geometry, it would have been a beautiful problem. Now what is given to you is 1:3. This is gamma delta, so this is -3 gamma, -3 delta. And we have to further find C. So this is 1:2. Okay, so if this is x, y, what you have is x plus 2 alpha by 3 is gamma. So x is 3 gamma minus 2 alpha. And in the similar vein, this is 3 delta minus 2 beta. Okay. Now, if you look at it very closely, these are DEF. Now, centroid of DEF is, if you look at it very carefully, 2 alpha, 3 gamma, they all get cancelled out. Centroid of DEF is 0, 0, which is your point K coincides with B. So you have to find GK, which is as good as distance between B and G. Okay, so this turns out to be a comparatively simpler exercise. 8 you take off outside. So this is 4 square plus 3 square. So this is 40. Isn't it? This is what? Length GK, this turns out to be 40. You understand that the angles that are given, sorry, the answers that are to be given are 2-digit numbers from 00 to 99. Okay, so you write 2 digits even when answer is say 4, you write it as 04. Now let me now move ahead. This is the x radii of a triangle are 21 by 2. So this is R1. What is R2? 12 and R3 is 14. If the sides of triangle are roots of x cube, okay. So sides are, that is x cube minus a plus b plus c into x square plus ab plus bc plus ca into x minus abc. This is the quadratic. So P is A plus B plus C, where A, B, C are sides. Q is AB plus BC plus CA, and R is ABC. So what we have to find is PQR. Okay, now R1, R2, R3 are known to us. So what we know is R1 is delta by S minus A. R2 is 12 and R3 is 14. Okay, S minus A, S minus. Further, S by delta. That, and now suppose if we have to find A, B, C, okay, let us first multiply them, okay. So what you get is R1, R2, R3 is delta cube upon S, S minus A, sorry, fine. In fact, if you multiply it by R, you will get delta square. So R you can very easily find. Okay. Okay, okay. So if you multiply it by R, it becomes, this is delta square. Also what we know is that will give you AB plus BC plus CA, okay. This you can easily find, ABC. 1 by R1, so R is delta by S. Okay, AB plus BC plus CA. We have to find the integer name. Okay, that we have to effectively find PQR. So delta square. Okay, we will get delta and then we will find that. Fine. Now 1 by R1 S minus A, S minus B, S minus C is, see when you add them up 3S, so this is 1 by R. So this is 2 by 21 plus 1 by 12 okay, so you will get R from here. So 7 for your 56. Why are we writing 7 again? What is the LCM? 3 into 7 into 4. So this is 8 plus 7 plus 6. So this is 8 plus 6, 14, 21 by, this is 1 by 4. So R is 4. If R is 4, you find delta. Okay, once we find delta square, so if R is 4, R into R1 into R2 into R3, this becomes 4 into 21 by 2 into 12 into 14. So 2, 2. So delta square, what is delta square? 2 into 3 into 7. 12 is 4 into 3 and 14 is 2 into 7. So, what is delta? 2, 2, 3, 7. So, delta is 4 into 21, 84. S you can find, okay, now S you can find, you know delta, R is delta by S. S is delta by R. So, delta you have found out 84 by 4, this is 21. So, S is 21, so A plus B plus C is now 42. Okay. Now, R1 is okay, A square plus B square plus C square, that is how you get ABC. S you know. Okay. Now, you see another important result that we have is 1 by R1 square plus 1 by R2 square is delta square S minus A, S minus B. So, you have plus S square. This is A square plus B square plus C square by delta square. So, you get A square plus B square plus C square, and do we have some expression for what is R1 R2 plus R2 R3 plus R. See, R1 R2 is delta square by S minus A, S minus B, S minus C into S, isn't it? So, this is S square. Okay, we would have found S directly. Okay, anyways, this is S square. Now, from these calculations, 1 by R1 square, delta square we are aware. These expressions we are aware, we can find A square plus B square plus C square. Once we find A square plus B square plus C square, we know this, we can find AB plus BC plus CA, okay. So, now let me do the calculation. 1 by R1 square is 4 by 441, okay. 4 by plus 1214, 1 by 144, 14 is 196 plus 1 by 16 is delta square is 84, okay. Delta I think is 84, so 84 into 84. Now, this is a very typical calculation if you think of it. So, what other way we can find AB plus BC plus CA? R1, R2, this is S square. Okay, what is S square? Okay, A plus B plus C whole square by 4. It will be more or less square plus, that will be calculative, AB plus BC plus CA. S we can get from there, okay. This is a very demanding calculation in my eyes. You know. What is A square plus B square plus C square? 84. See, 4 into 84 into 84 by 441 is 21 into 21 plus 84 is sorry plus okay. So this is 4 4. So a square plus b square plus c square is 64 plus 49 plus 14 into 6, sorry, 36 plus 441. So this is 10 times 0, 2, 4 to 6, 3, 9, 4, 13 and 6, 19, 590. This is a square plus b square plus c square. We already know a, b, c. So we have known a plus b plus c, I think we calculated as 42. 42. A square plus b square plus c square we have calculated as 590. 590. So from here we can say 42 into 42. So 42 square is 1604 plus 320. 1604 plus 320 is 1924. Okay. Isn't it? 842 into 4, 168, 88. What is 42 square? 40, 1600, 40 into 2 into 2, 160, okay. 1600 plus 160, 1764 is 590 plus 2 times AB plus BC plus CA. So AB plus BC plus CA eight 295. So 7 8, this is 587, AB plus BC plus C. Now the only thing that is left is to find AB plus BC plus C, sorry, A into B into C. So we know S into S minus A into S minus B into S minus C is 84, that is 21 into 4. Okay. So you get 21 cube minus 21 square into a plus b plus c, which is 42, plus 21 into ab plus bc plus ca. So you calculate ABC as 21 cube as 21 into 587 7 5 4, isn't it? 0 3 1. So 21 into 130. 13 1 ja 13. 2730. So this is ABC. So ABC is 2730. This is 2730. This is 587. 587. Now you have to add all of them. So this is 9, 8 plus 4, 12, 3, 15, 1, 6 and 7, 13, 3, 3, 5, 9. So this is root of 3, 3, 5, 9. So 60 square is 3600 to 60 minus 1 whole square is 3601 minus 120. 3481. Okay, 3481. So 58 square is 3600 4 minus 240. 3364. So the nearest integer to this is going to be 58. So you look at the calculation involved, maybe the solution could have been simpler. I just whatever identities I could remember, I just penned it down. But look at the time it has taken, and maybe there could have been a better way to calculate it. I don't deny it, but just I took a question. I thought it is very doable. I just took it, so I think there might we might involve better identities to solve it. That I am not denying it, but just whatever is struck to my mind. Okay, this is the utility. Even though I don't find that this question is very good, or it is up to that point where it should be asked in examination, because it is asking so many facts. Formulae application, explicit application of formulae, I don't think so that is the intent of paper setters. Anyways, it has been asked, we cannot deny it. Now the next question is, in a triangle ABC, let E be the midpoint of AC. Okay, in triangle ABC. E be the midpoint of AC. And F be the midpoint of AB. the medians BE and CF. The medians BE and CF intersected G. So this is what we say is centroid. YZ, okay. YZ are midpoints of BE and CH. Okay, ZYZ. Okay. Now we know area of triangle BGC. Area of triangle BGC is 1/3 area of triangle ABC. So here it is 160. 1/3 of 480. I think we can very easily conceive of this notion. Okay, that they are all parallel. That much I think we don't need to prove is very explicit. Now if these are similar triangles, so we know BGC. Now this is 2/3 of this median. BY is half, so 2/3 minus half. So if BE, see if BG is 2/3 BE, okay. So GY is 2/3 minus half of BE. So BE by 6. So BG by GY, okay. BG by GY is so GY upon BG is 4. And now we are through. These are similar triangles. We have found the ratio of sides. Okay. If this is the ratio of side, ratio of areas will be square of it. This is 160. So area of triangle GYZ is going to be 10 square units. Okay. See, the previous problem just involved calculation. These are better problems. These are the problems that are meant to be asked in examination. Fine. So now moving ahead to our next problem. So you are given a triangle ABC with AC side, one of the side is given as 20 is inscribed. So you are also given its circumcircle. A tangent is drawn to it to omega through B. Okay, at vertex B you are drawing a tangent. Fine. You draw a tangent at vertex B. Fine. Now this has been named as T. Now the distance of T from A is 25. So you draw perpendicular from A to T, perpendicular from C to T. This is 25. This is 16. If S denotes the area of triangle ABC, okay. Now let us first assume, say O is the circumcenter. This is 90 degrees. Say these perpendiculars are M, N. Right? Now let me now we have to find area of these triangles. One of the sides is known to us 20. Now, if you look at it very carefully, see these are perpendicular. So whatever is the length of perpendicular from O to AM. So this is MNOP, say S. So these two are going to be equal. This is a rectangle. Now we can find OS by saying this is 25, this is 25 minus R. This is R, so we can find OS as 25 into 2R minus 20. This is OS. And therefore, we can say AB is root of 25 square plus 25 into 2R minus 25. So, AB is 5 root 2R. In a similar vein, we can say BC is 4 root 2R. Let me not get involved in all the calculations. Now, insofar as area is concerned, area is half AC into AB into sine of angle between them, sine A. So, half AC is 20. Okay, what is AB? 5 root 2R. And sine A. So, BC is 4 root 2R. This is 2R sine A. So, what is sine A? 4 so 2R, 2R, 2R. 2 is 10. So, delta is 200. Okay. So, this is S, sorry, so S by 20. S by 20 is nothing but 10. So, these are better problems. These are much better problems that we have gone through. Okay. So, moving ahead to our next problem. This is again a problem from probably 24 or 23, that in a parallelogram ABCD, a point P on segment AB is taken. In parallelogram ABCD, AP is to AB is 61 is to 2022. AP is to AB. So, this is 61 lambda, say for example. PB would be 2022 minus 61, 1961 lambda. And a point Q on segment AD is taken 61 by 2065. Okay. So, two 5 minus 1, 4, 6 minus 6, 0. Okay. This is the situation. AD such that if PQ, now we are drawing PQ. This is the line PQ intersects the diagonal AC at T. So, we have to find AC by AT to the nearest integer. Okay. So, in the section on geometry, lot of questions were done when you were given, suppose something like this, you draw a line parallel to the base, isn't it? So, something like that we are going to do. You see, this is 2004, this is 1961. So, if I draw a line parallel to PQ I can draw either from B or from D. If I draw from this is 196, okay. If I draw from D, since this is 2004, if I draw a line parallel, it will meet outside this parallelogram. So what I am preferring is I am drawing it from B. Okay, and let it meet here at E, and this is say F. So that see, I think you are able to gauge this fact that what this will yield is that this much part by the basic proportionality theorem is 1961 alpha, and this much part whatever is remaining 2004, and this is 1961, 35 alpha. Okay, no, 2004, 33 alpha, 2022 plus 33, 33 or 43, 2043, 43 alpha. Let us see what will be utilized, okay. Now, by similarity we will be proceeding now, okay. So, we have to find, what we have to find is AC by AT. So, we can find AE and then AC, okay, fine now. Now, if you look at it properly, these two are definitely similar triangles, APQ and ABF, they are similar triangles. So, we can find ratio of AT-AE, okay. Okay. First and foremost, what we do is that this triangle and this triangle, these two triangles are similar, okay. AEF, BEC, these two triangles are similar triangles, okay. This angle, and these has to be equal. So, we can say opposite to this angle is AF and opposite to this angle is BC. And opposite to this angle is AE, is something that we are interested in, and opposite to this angle is opposite to this angle is EC. Now, AF is 2002 alpha, okay, sorry 2022 alpha, and BC is 2065 alpha. So, we get AE by AC, and now you can see we can find now AT by AE, and that we will be through. So, AE upon EC, you can also see if you add 1 to both the sides, AE upon AE plus EC is nothing but AC, and this is AE upon EC. So, we would like to have AE with us. So, let us say EC upon AE, and then we add 1. So, you get AC upon AE is 4087 upon 2022. Fine. I think we can say EC upon AE and then add to both the sides. See, I think the rationale behind this is that These two, again we will deal with two similar triangles and then we will conclude. So, we have found AC is to AE. Now, we can find from these two similar triangles, this one and this bigger one ABF, two another similar triangles, because we have drawn this parallel to PQ itself. So, we will be able to find AT by AE. So, I think now we can very easily conclude that AT by AE by similarity would be 61 upon 2022. Okay, this is this triangle and this larger one ABF, they are similar triangles. Now, we have to find AT by AC or AC by AT. So, it is basically nothing but 4087 upon 61. So, the nearest integer 61, we can say 408. So, 6 is 36, 366, isn't it? So, 408 and 366 to 427 is, in fact, it is an integer in itself. The answer is 67. Okay, so no point discussing nearest integer, it is actually an integer. The answer is 67. Fine. So, simple application of basic proportionality theorem and we are through. Similar triangles, you get basic proportionality theorem by similar triangles only. So, that is why if you knew the proof, if we have done basic proportionality theorem at the very initiation, this is how we initiate. You draw a line parallel to the base to come to the conclusion that we are looking for. A beautiful problem, a question on geometry. Lot of questions that we have done did require a lot of notion of trigonometry. Okay, but here it is a pure geometry problem. So, in that sense, it is a beautiful problem. Another question is in a trapezoid ABCD, the internal bisector of angle A intersects the base BC or its extension at point E. So, you are drawing bisector of angle A. So, let this be A. Base is BC and the triangle in discussion is DAE. Okay, AB. So, let me say this is ABCD. Fine. Now, you are drawing bisector of angle A. These two angles are equal. Okay. This is the figure that we have drawn. It could be outside, but I think it is, but it will not. It is not going to change the overall scenario. So, if this is theta, this is also theta, this is also theta. We have to find angle DAE, that is whatever angle you say, this angle or this angle. Now, ABE, okay. Inscribed in the triangle is a circle touching the side AB at M, okay, okay. AB at M and side BE at P. So, you are drawing in circle to this triangle. This point is M and this is P. Further, AB is to MP's x. So, if this is x, AB is 2x. Okay. If this is x, AB is 2x. Now, we have to find this angle. Okay. So, we have to find angle DA in degrees. See, if you are able to look at it very carefully, Hmm. These two are equal, these two. This is equal to this. Tangents from external points. Okay. Since these two are equal, this is basic proportionality theorem again. These two are going to be parallel. Okay. Okay, fine. I think you are able to gauge this. This is x. See, this is equal to this. So, base, this is the basic proportionality theorem. No, but why are these two equal? Yes, yes, yes. Lengths are equal. Sorry, my mistake. No, these two sides are equal. This is theta, these two sides are equal. So, since these two sides are equal, BE and AB are equal, these two are also going to be equal, so they are parallel. So, these two triangles are, this angle will also be theta, this angle will also be theta. Now, okay. Now, I think you can very easily make it out, okay. What we have to say is that, fine, if this is y, this is y, this is y, this is y, this is 2x minus y, and this is 2x minus y. Now, we can say x upon 2y, okay, x upon 2y, similarity we will use is 2x minus y upon, what is this whole length? 2x, isn't it? So, this 2 gets cancelled, you have x square is 2xy minus y square. So, x square x minus y whole square is 0. So, x is equal to y. Okay. So, all in all what we are getting is that in this triangle ABE, let me draw it separately. ABE MP. So, this is x, 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 x. Fine. So, you can see that it is an equilateral triangle. I do not think so we need to extend it any further, okay, because we know what these lengths are. This is S minus B. I hope you recall, this is S minus B, this is S minus A, this is S minus. S minus A is S minus B is S minus C, so ABC are equal. So, all the angles of this triangle are 60 degree. So, theta is 60 degrees. Another problem on basic proportionality theorem. That is what I am saying, the basic things that we have gone through, they are ultimately the questions that are asked in examination. Okay, not see, if you see, rarely you come across questions which asks you Severs theorem, Menelaus theorem, at least in IOQM. Even though that we must know it, because as we move on to next stages, it will be necessary that we know them. But at this stage, look at the beautiful problem they have asked. This is really a very good problem. Another problem, see, let ABCD be a unit square. Suppose M and N are points on BC. Suppose M and N are points on BC and CD respectively, such that the perimeter of triangle MCN is 2. So let me draw this in a separate slide. This is a square A, B, C, D. M is on BC and N is on CD. M is on BC, N is on BC. Okay. So perimeter of this triangle, which triangle? MCN. MCN, that is what? MCN is 2. Fine. Let O be the circumcenter of triangle MAN. Okay, we have to draw triangle MAN also. Let it has circumcenter somewhere, say O. Is it called O? Let me. O be the circumcenter. And let P be the circumcenter of triangle MON. Angle MON. Somewhere, see here. Maybe outside, I don't know. For convenience sake, let us assume this. Okay. All in all, it is going to be like this, I think. If this is theta, this is 2 theta, and this is 4 theta. Fine. OP upon OA whole square is something that we are asked for. OP upon OA whole square. Now, sum of these two sides is 1 plus 1, 2. Perimeter is also 2. That means BM plus DN is MN. So, now let us say if we say this is X, this is Y. Okay, so this would be 1 minus X, 1 minus Y, and this would be X plus Y. OP upon OA. This is P. Okay. So, drawing two circles would make this a very cumbersome thing. So, let us not get involved into it. I have already mentioned the angle theta. So, what we have to do is that these are circumradius only, na? OA. So, let us say the triangles R2 by R1 whole square. Also, we can say MN is 2 R1 sin theta, isn't it? And it is also 2 R2 sin 2 theta. So, R2 by R1 is sin theta upon sin 2 theta. So, this is 1 upon 4 cos square theta. So, all in all, this question has now reduced to determining this theta, in case we are able to do so. This is x, this is 1, this is 1. Now, we can also have a geometrical thought on this. Otherwise, if you look at it, we can go by brute force. This is root 1 plus x square. This is root 1 plus y square. Y and x are related by, see, this is a right angle triangle. So, x plus y whole square is two xy is 2. So, it is x, so y is 1 minus x by 1 plus. So, this is one relation. So, one thing is to go by brute force, that this is root 1 plus x square. So, x plus y. Let us first go by a brute force method, okay. Sorry. So, Mn is x plus y. So, it is x 1, this is Mn. An is root 1 plus y square. Y you already know in terms of x will cos theta. I am assuming that we get it independent of x. Then only this question has any meaning. So, first we are doing it by brute force, then we will see a geometrical way to get into it probably. We will try to think. At the very first instance, we are doing it by simply brute force method. Let us put this, let us put this. Even though I think we should, okay, let us try once we have started now, we should not change the course in between. So, cos theta, let us write it next. Cos theta is AB square, sorry, AM square plus AN square, okay. AM square so AM square is 1 plus x square plus AN square is 1 plus y square, okay. Okay. 1 plus y square minus Mn square. Mn square is x plus y whole square upon 2 so what do you get? X square y square gets cancelled, it is 1 minus xy, isn't it? 2 my upon now we will substitute y. What is y? 1 minus x by 1 plus x. This is okay. Root. So, this is 1 plus x upon, see, 1 plus x will get cancelled out. and 1 plus x square, and this is again 1 plus x whole square plus 1 minus x whole square. So, this is root so this is 1 plus x square it incidentally turns out to be independent of x. See, because this question had an answer, fixed answer, I was pretty sure that x will get cancelled out. Otherwise, if it turns out to be a function of x, then the question becomes meaningless. So, we were pretty sure that it will turn out to be independent of x. Insofar as the question is concerned, this is so 1 upon 4 cos square theta, or simple 1 upon 4 cos square theta is 1 upon 4 into half. This is 1 upon 2. So, this is simply brute force method. Students preparing for Olympiad are not expected to, are generally, I would not say not expected, are expected to use some elegant geometrical way. I do presume and I still believe that there is a good geometrical way to deal with it. Okay. Let me tell you one of the ways. So, you are drawing this figure. Geometrical methods are very elegant when they work out. The benefit of having algebraic method is that they are very process oriented. But again, then the charm is lost, that cannot be denied. This is theta, this is alpha, this is beta. Okay. So, one thing is that alpha plus beta plus theta is 90 degree. So, we already know the answer. We have to show that alpha plus beta is theta. Okay. So, the alpha plus beta is theta, but again, even otherwise, what we do is that we rotate this triangle ABM by 90 degree. So, B comes to point D, M shifts. Okay, see this triangle ABM, we just rotate it by 90 degree. So, where do we land up? This gets horizontal, this gets vertical. So, AB coincides with AD, M has now reached the point M dash, and this is alpha. This is root 1 plus x square, this is root 1 plus x square. This is y, this is x. Okay. So, you can very easily see, what you can see? Triangle ANM dash and triangle AMN are congruent. You can see all their sides are equal. X plus y, x plus y. I think this is why the problem was asked, not the brute force method. That are you able to conceive, are you able to think around these lines? And now you can very easily see alpha plus beta is theta. Okay. So, you have theta is 45 degree. Rest all is a trivial conclusion. Fine. If we are not able to come up with an elegant geometrical solution, then definitely properties of triangle, solution of triangle, trigonometric, or so to say algebraic methods are definitely advisable. But as a mathematics student, definitely this gives you more joy and gives you goosebumps than solving it by brute force method. Again, in the examination, we have to do better than others. So, we have to be pragmatic and take an appropriate call. Okay, it is not about appreciating the beauty of the problem, it is about solving the problem then. So, whatever method turns out you are able to think of first, that is the way you should proceed. Okay, because on occasions some laborious problems have been given, as we saw in R1, R2, R3. Okay, that we did by simply putting in values. No thought process was involved as such, and we used certain facts. Okay, so this concludes this session and the whole series of geometry. As we move on, we will probably come up with one more session where we will take more PYQs. Here we have taken some PYQs based on our assessment of the different sort of problems that you encounter. So, we saw problems that could be solved by purely geometry. We saw problems that involved only formulae. We also saw a problem where we involve bit of trigonometry and bit of geometry. But again, the substantial content is definitely pure geometry. Okay, and if we have a notion of trigonometry and if we are comfortable with the properties and solution of triangle, we have an extra edge, that in case we are not able to think of a very elegant way of dealing with the situation, we are able to do it otherwise. So, I hope the whole series, the whole geometry series and the other series that you are continuously taking up is helping you in your preparation and is helping you gain confidence in so far as questions is concerned. And the simple aspect which I have said right from the very beginning to this last session is that knowing the basic notions and their proofs would go a long way in dealing with the problems that you are ultimately going to encounter in IOQM. This session, the depth of the coverage, especially the problem part, is limited to IOQM. You have seen that as we will move on, we will take up another sessions post IOQM, and probably before IOQM we may take up one another geometry session, lengthier geometry session where we will take more PYQs. Thank you very much for motivating us and encouraging us so that we keep on running this, and I am absolutely sure that you will keep on motivating us and your feedback would help us in coming up with better series now onwards. Thanks a lot.